Hi Naomi, do you want to show me something?
Yes, look, Maman. I've got some type of superpower. I can control the light remotely. So you see, when my hands get closer to the light bulb, the light turns on.
Whoa! May I try?
Sure, try it, but you don't have any superpower.
Well, it doesn't work. Please explain.
Yes, I'm gonna explain it to you. But first, let me introduce you to our project. Here is the picture of the current team, and here on the right is the picture of Cynthia, the student you see in the wheelchair. So she is affected by a degenerative neurological disease that causes hand deformities. And because of that, she struggles doing simple actions like taking the bus, for example. So in order to simplify her everyday life, we managed to create a new contactless system that doesn't require using your hands.
Indeed, you all know the current contactless, which consists of placing your smartphone on the emitting antenna of a payment terminal. This simple gesture is very difficult for a person with a disability like Cynthia, so the main idea of our project is to keep your phone in your pocket and to place any part of your body on the emitting antenna, like this.
But, Clément, to be able to identify us, are you going to introduce some chips into our body?
No, don't worry, Marin. Neither chips nor biometrics data. The body just transmits the information from the emitting terminal to the smartphone using our body. Indeed, disabled or not, we'll have a body, haven't we? Otherwise, there is a problem.
So this is possible thanks to the electrical properties of the human body. So first, it acts as a conductor, but most of all, when it is paired with an antenna like this one, which is also located inside this orange box, our body acts as a capacitor. So let me show you. When I put my hand like this, my hand and the antenna are both the conductive plates of the capacitor, while the orange box is the dielectric. So that's actually those two properties that are going to enable the communication between the emitting terminal up to the smartphone inside the pocket via the human body. So first, I'm going to replace the smartphone by a second computer right here, which is linked to the reception circuit, itself linked to the receiving antenna. And you can see that on the screen of the second computer that nothing is appearing at the moment. And as an example, I'm going to send a message from the first computer up to the second by using my body. So the message I want to convey is this one. It starts as D481F. And when I'm going to put my hands on both of the antennas, you will see the exact same message printed on the screen of the second computer. So you see that the characters that are scrolling down match exactly the ones sent by the first computer. So now I'm going to explain more precisely what's happening within our device. Well, first, the message I showed you is sent as a binary signal through the USB ports up to the emitting circuit. And we can observe this binary signal on the oscilloscope. It is the yellow signal, and we indeed distinguish the ones from the zeros. So the ones are when the voltage is positive, whereas the zeros represents the negative voltage. Next, on this emitting circuit, we have to generate a carrier frequency of 4055 kHz. So again, we can observe it. This time it is the blue signal, and if I zoom in, we observe the maintained oscillations that set up our carrier frequency. And last but not least, we have to modulate this carrier frequency by the binary signal we want to convey. And this is possible thanks to this little component, which is called a transistor MOSFET. And in order to activate it, I have to lower down this tiny switch. So from now on, the blue signal is the modulated one. And we can again distinguish the ones from the zeros. So when the carrier frequency is emitted, we send binary ones, and when it is not emitted, we send binary zeros. So then this signal is sent to the emitting antenna. It goes through my body and comes to the reception part.
Okay, I understand. So, in this reception circuit, the reverse path is operated. So, from the modulated signal, we retrieve the initial binary signal.
Yes, exactly. So this is done for the most part by two circuits in the reception one. First, there's an envelope detector circuit right here, and the second circuit is a comparator circuit created with this operational amplifier.
I have a question. Is it this reception circuit which is integrated into the case of the smartphone?
Well, sort of, but not exactly. I'm going to show you on the slideshow the problem we faced. So in the circuit I just showed you, the emitting and receiving parts are both linked to the electrical ground. However, in our final device, the reception circuit is integrated to the smartphone, so it must be cableless because we obviously do not want to be walking with the cable hanging. So we have to find a solution. So the solution comes from the thesis of Kibret, a researcher that, according to which, the human body acts as a cylindrical antenna like this. So we already knew that our body could be modeled as a receiving antenna because we already all have made the experiment of putting our hand close to a radio antenna and see the reception improvement. From now on, thanks to Mr. Kibret, we also know that our body can radiate waves. So look now. When you're going to come close to the antenna, you're going to receive the waves and radiate them up to the smartphone inside your pocket. Hence the fact we had to change the reception circuits by replacing the envelope detector circuits by a component which is called an AD8310, located right here. And this component is actually a logarithmic amplifier capable of picking up a very wide range of radiations, such as the little ones that our body radiates. Notice also that on this reception circuit, you find again the receiving antenna. And the compound creates the Intra Body Communication, IBC for short, contactless technology of the future, integrated to the smartphone case. Like that, with which Clément is going to make a demonstration.
Thank you. So to use our device, we just need to put the phone in its case and to plug it into the USB-C socket right here. So we developed an app with Java which transmits an image from the emitting terminal to the smartphone using our body. So, okay, I'm going to start the demonstration. So here we have the image we want to transmit. So it's the EUCYS logo. And when I'm going to put my hand on the emitting antenna, the image will be transferred. So we can see that each pixel is transferred. Step by step, the image appears. So we reused that phenomenon in our final device, which goal is to help disabled people like Cynthia when they are in the bus or in the subway. So I'm going to restart the demonstration. Okay. So our final device is composed of three main elements: the emitting terminal, which is connected to the emitting antenna, the server, which handles every user's ticket, and the smartphone, which especially allows users to buy a ticket from anywhere. So that's where I will start. I'm going to buy a ticket, so I click on the shop icon and I buy one ticket. You can see that I have one ticket. The smartphone just communicated with the server to buy a ticket. Now I put the phone in my pocket and I place any part of my body, so my arm for example, on the emitting antenna.
Access authorized. Opening of the door. You don't have any ticket left. The door will close in 3 seconds.
So what happened? When I placed my arm on the emitting antenna, I created a connection between the terminal and my smartphone using my body. This connection allowed the terminal to send this message that Naomi previously mentioned. Then the smartphone sent back to the terminal my information, so the user information, in this case it was my information, by encrypting them. The terminal requested the server to know if I was authorized to use the subway or the bus. So it was the case because I just had one ticket, and the door opened, et voilà.
So eventually, we managed to create a new contactless system useful for everyone, for disabled people like we saw with Cynthia, but also for non-disabled people because it can prevent snatch theft. And we're convinced that the IBC technology is the contactless of the future that will replace nowadays contactless.
But Naomi, in fact, you don't have any superpower. You had to hide an emitting antenna.
Well, no, Mama. I don't see what you're talking about.
Let me check something. Hey, what is that? Oh, that's your superpower. You put your foot on it to create an antenna.
Well, okay, I surrender. I indeed hid an emitter, allowing me to control the light. So when I put my hand on it and when my other hands get closer to the reception box, it gradually turns the lights on. And look, I can also realize a binary transmission if I switch this button right here. And if I switch this one on, it activates the sound.
Wow.
So thank you for your time. We hope you like our presentation and we're ready to answer all of your questions. Thank you.
Thank you.
I do have to admit that was a pretty impressive demo.
Thank you.
You guys clearly put quite a bit of effort into it.
We did, yeah. It was a lot of preparation.